Good morning or afternoon, depending on where you are in the world. This is Doug Cluck from NOAA, National Centers for Environmental Information, based in Kansas City. Today we're going to have a webinar that includes what we like to call the mothership down in Asheville, North Carolina. And two people, Karen Gleason and Deke Arndt from the monitoring branch down there, and they're going to be talking a lot about, well, they're going to give examples of some of the information that they produce on a daily, weekly, monthly basis that helps us all tell the story on what's going on, what has happened across our areas, our regions, at various scales. They're going to hone in somewhat on the north central part of the U.S., where most of the folks that are probably on the call live and are concerned about. So this isn't an outlook. This is actually looking at data and what we call monitoring of the climate. So I'm going to turn it over before I run out of words. What I also will say, though, is at the end of this, we'll go through any questions that you all have. There's two ways for you to put questions in as we go. One of them is on the webinar itself, there's a question area. You can type in a question if you have one, and we'll get to those when we're done. The other way is also when we're finished with the presentation to raise your hand. There's a little way to raise your hand there on the interface, on the attendee interface or something like that. Anyway, we'll get to you if you have a question, one way or the other. And I think at this point I'll say, Deke, I think you're going to start it off, so take it away. Thank you.
Yeah, thanks, Doug. Can you hear me?
Yes.
Okay, great. So I'll talk a little bit. Doug's probably going to shoot the screen control over to Karen, but basically to set up what we'll discuss today, we're from the Climate Monitoring Group at the National Centers for Environmental Information at the mothership in Asheville. What we do is kind of the play-by-play of the climate system. And today we'll talk about, again, focusing on the central region, particularly the northern plains of the U.S., some tools that we have that you may be able to use from a climate monitoring sense in a couple of ways. So that we have about 150 different products and tools that we call. We're going to focus on 2 or 3 of those today. And if you have questions, we may be able to incorporate a few more, but it gets to be overkill when we try to explore the whole catalog. So we're going to walk through kind of the main monthly climate monitoring products. 2 in particular, the Climate at a Glance tool, which is kind of where you can go get the climate history of your part of the world, and whether you see on the county scale or the regional scale, you can do that. So Climate at a Glance is kind of the story of your climate since 1895, and we'll talk about our U.S. monthly climate reports, which have kind of information about what is going on. We deal mostly with the what and the how much in climate monitoring. We do a little bit of impacts assessment, and we do a little bit of trend analysis. We typically don't ascribe the relationship of individual events with the changing climate. We tend to report specifically what has happened, how big is it, how does it fit into history, is it part of a trend or is it not part of a trend, and so on. That's kind of our role, is to be the scorekeepers of the climate system, and increasingly to make our data available to people so that they can kind of keep score on their own. And I think with that, I think we'll hand it over to Karen, and she's going to drive and kind of narrate our way through a couple of these products, and I may chime in once in a while.
Sounds good. Thanks, Deke. First of all, I just want to be sure that my screen has been shared. I don't know, Doug, if it's been shared all along here, but just want to make sure that folks can see my opening slide.
Yeah, it's the opening slide is NCI climate monitoring products. So
perfect. All right.
Yeah,
so then we'll get going here. All right. There we go. All right, so the topics we'll cover, Deke already hinted at this. We're going to take a look at sort of our flagship product that we have in monitoring. And actually, Deke and I were just talking about this. We're coming up next year on a 20-year anniversary for this tool, and boy, has it come a long way since 2000 when we first created it. So we're going to talk about how you might use this and for what purpose, look at the different types of monthly output and the variety of scales that we have with this, and we're going to generate some dynamic graphics and look at our output options. We'll talk about the monthly climate reports, when they're available, what's included in them, and how you can connect via our webinar, which you are more than welcome to do each month. And then if we have time, there's a third topic and we wanted to get into, especially since it's been wet, very wet in the central part of the country lately, and that's our Climate Extremes Index, and take a look at some of the indicators in that help us quantify and take a look at how extreme either the temperature and or the precipitation have been over various seasonal, monthly, seasonal, annual scales. I have a picture here on this particular slide just to indicate that none of this would really be possible without a database and a host of data that come from individuals who have meticulously collected data over time. And so we just want to recognize all of the observations that are made that we archive here at NCEI, that we tap into in order to be able to perform these comparisons of the current weather to the historical record and putting it into context. All right, so with that, we'll go ahead and we'll get started here. So the first product is our Climate at a Glance, and this tool was really developed. It wasn't meant to be a power horse, workhouse kind of product. It was meant really, to quickly get an idea for how recent weather compares to the historical record. And so we're really interested here in climate variability. If you're more interested in just knowing what was the high temperature on a day, or how did a particular station end up for a month, the Weather Service might be a good place to go to just kind of get that information. But if you want to know what just happened, say for instance in May, how that compares to its historical record, this is the tool for you, and we would recommend you use it in that sort of way. You can do a quick search for historical content for temperature variables, precipitation variables, and a number of drought variables as well. The time scales go from individual months, nothing shorter than a month, to multi-month periods all the way up to 60 months. Year-to-date is a common multi-month period, as well as annual and the 4 seasons. There are also many spatial scales that are available, and I think Doug hinted at this. It goes all the way from a global perspective down to a contiguous U.S., a national perspective, regional, states, divisions, counties in red here because it's one of our most recent additions, spatial additions to the Climate at a Glance system, as well as data for 200 some odd cities across the U.S. The types of output that are available, as you'll see, you can download tabular data in a variety of formats. We have maps, we have time series plots, ranks, which is kind of what we've been doing for decades here, it seems like. And also in red, we have listed Haywood plots, which we more colloquially call horse race graphics. So if you're familiar with those, if you're interested in, say, how your precip has accumulated throughout a season or throughout a year, and you want to compare it to other like periods in your historical records. So we have the ability to do that. And we'll try and take a look at many or most of these as we move through the presentation. So with that, I'm going to pretend like I just clicked on the link on the bottom of the presentation here, but what I'm really going to do is just switch to my browser.
And while you're doing that, Karen and I are both going to say precip, and we mean that in place of precipitation. I'm from Oklahoma. I can't do more than 2 syllables at once. So we're going to say precip, even though we're told by our communications people to never do that.
All right. So when you click on that link that was on the bottom of the presentation, it takes you to a global map. Don't let that fool you if you're not interested in global information. We have several navigation toolbars at the top of the Climate at a Glance page, and the default is the global. That's the main page. chances are you're most likely going to be interested in just a national perspective if you just want a quick look at what happened across the nation as a whole, but most likely regional, statewide, divisional, county, and city data. Those will probably be the various spatial scales of interest, and we'll take a look at examples from those. The secondary menu system, you can look at maps of things, so you can look at actual values, ranks, anomalies, that sort of thing. Time series plots for an individual location or a region or a state, and look at that one particular piece throughout time. Rankings, which, we have 125 years of continuous record for our counties, our divisions, state, region, and nation, so you can drill down throughout all of those years. Again, I mentioned the Haywood plots. We'll take a look at some of those. And then we have the obligatory background information on the data that are included, where they come from, and so forth. So to just kind of step in here, I thought I would just kind of take you across the bar, and I probably won't spend too much time on national information, because I think where the true interest lies here is probably in the regional and the statewide and the more local perspectives. But if you look at just the base tool, you get to select a parameter, and these are all the different parameters that we have available at the present time. Not all parameters go with all types of analyses, but we'll restrict our menus when we can't provide data for a particular analysis. So we have a parameter, you choose your year throughout history, goes all the way back to 1895, as I said. You identify the month of interest. So for 2019, we only have 5 months so far worth of data, so it'll limit your selection. And then your time scale. Do you want a single month analysis, or would you like a multi-month analysis? And once you've selected your various items that you're interested in, you click on plot, and the default here is a map that just tells you what the average temperature was for the month of May, because that's our most recent data month. So if you hover over the map like I just did, it'll tell you what the average temperature was, where it ranks amongst the 125 years. It'll tell you what the mean value is and the anomaly based on the actual value and the mean. And the mean is based on a 20th century average. So down at the bottom, we have a bar that tells you where that temperature falls. And as I hover over the U.S., a little icon shows up, a triangle that tells me where I'm at, and I'm almost at 60 degrees there. And then there'll be a data table below. So this is really simplistic for the nation, because it's just one data point. So what I'm going to do now is I'm going to go to a statewide analysis. So now we have a little bit more data and information to look at. So they're giving me the default or values, so average temperatures for the month of May. If I want to know, if I'm not real sure what the value really means and I want sort of some context, I might click on this button that says ranks, and that button will all of a sudden transform the map and tell you that, from the Rockies throughout the Northern Plains, it was quite cool throughout the month of May. And the state of Washington and most of the Southeast were very warm for the month, and Florida was actually record warm for the month of May. So we can actually, this is all interactive, so if at this point, if I didn't actually want to drill down using the menu, if I wanted to actually click on something in the map, I actually can. And so for instance, temperature wasn't nearly as big of an issue in May as precipitation was for a large part of the central U.S. So I'm actually going to switch to precipitation so we can kind of get a glance at how state by state, and then we have ranks here. So let's see here, precipitation month of May. All right, so we have, Nebraska, Kansas, and Missouri were record wet. So this color here in the center symbolizes no other May in the last 125 years was wetter than this month. And I imagine a lot of you were thinking, yeah, I'm in agreement with that based on my own experiences. So I thought it would be interesting to kind of take a look at Kansas here, which had an average of 10.40 inches throughout the state for the entire month, which is a tremendous amount of precipitation. I kind of want to see how this compares to other Mays. I know it's the record wettest. So if I actually click on the state here, it takes me to a ranking table that gives me a little bit more information. It tells me what the mean was, what the anomaly was from that mean. It tells me where it ranks and gives me some comparison to other years' records. But what I really want to do is I want to see how this compared with its historical record and be able to view the entire record. No, that's not what I wanted to do. All right, so I'm going to actually, I think this will carry over. This is coded in such a way that it has some memory, and it probably will hold on to Kansas if I did this right. So I'm actually going to click on time series at the top, because I don't want to see a ranking table at this point. I want to actually look at data through time. And so it does have some memory. So here's the time series plot, and it goes from 1895 to 2018, and we see that we have an outlier here. We knew it was record wet, but we didn't know by how much. And if I kind of want to do a real quick glance at how wet it really was, I can toggle the data table that's below the graph is interactive, and so you can sort by date, sort by value, least to greatest or greatest to least, or by rank. And so I'm going to sort by rank because I know that 2019 was the wettest. So if I click on it once, it'll go to the driest year. If I click on it a second time, it'll take me to the wettest year. And so we now know that 1995, which we could eyeball from the graph, the plot, was the former wettest May on record, and we exceeded that record by a little over 1.5 inches. So that's a pretty big deal to break a record by that amount when we're talking, almost 9 inches to almost 10.5 inches. So you can download this table. There's an XML format. You can download CSV format if you want to use it in a spreadsheet like Excel, or there's also a JSON format. And so the data you can just download in one click if you actually want to do something more with the data. You can also manipulate the graph. You can stretch it, you can shrink it, and you can do that for both the X and the Y axis if you're interested. So that gives you an idea of how to do an analysis for a particular state. Now, I might say to myself, well, it was a wet May, but how does Kansas look so far for the year? Like, what's our pace throughout the year? So I might want to click on this Haywood plot tab to take a look and see how Kansas is doing for the year. And we really like this. This is something that we're very excited about because we created these plots for other types of analyses, especially in our monthly reports. And now we actually have a way to create them with dynamically using data in our database. So a brief explanation of how this works. So the default, it starts in January and it ends in December, and then it lists the total value of accumulated inches on the y-axis. The current year is in this beautiful NOAA blue color, and if you hover over it, it will highlight all of the data points. So we see going from April to May, there was a huge leap, and in fact, it's actually the wettest year to date by just a little smidge compared to its neighbors. The other highlighted years that are listed here are the 5 wettest years for the entire annual period, so January through December. And so you can take a look at those values, and also for comparison, we have the 5 driest years and what they look like, and we compare that to the overall historical average. What you may or may not be able to see is in between are all of the other years that do not fall in the 5 wettest or the 5 driest. So you can take a look at a little bits of them as well. And then below, just like before, you have a data table. This is a little tricky for year-to-date periods because 2019 in May, it's going to seem a lot less than everybody else because everybody else, all the other years end in December. So we don't have a real easy comparison for that. You can look at all months instead of just end of the year, and then you can try and sort for all the months and then parse out the data you want, but that's a little more complicated. But this tool's really fun, especially as you get towards an end goal, whether it's a calendar year, a water year, whatever type of subdivision you want. You can go back to the top and you can choose a different start period if you want. So for instance, our friends out in the West, they might be more interested in a water year. So they might look at, July to June or something like that. But you can do this for precipitation is probably the most widely used, but you can use this for other elements as well. But I think we primarily use it for precipitation. So with that, I kind of wanted to give you an introduction, if possible, to some of our county data, because that's an exciting new spatial scale that's been asked about for many, many years. And we're finally able to serve that up in both a bulk way as well as a dynamic way. And so what I was hoping to look at was, I think, Missouri for the month of May. And I think I wanted to do mapping first. Oh, and it resets. So let me go back to Missouri. All right, so here we go. Plotting the map. All right, so we see several counties in Missouri that were record wet in May, and you can hover over each of these counties and you can see what their statistics are. I believe the one in particular I was looking at earlier today was for Barton County. It had over 17.5 inches of precipitation, which is a crazy amount for a given month. And I wanted to see the time series, see how it compared to the previous record, because it's actually quite astounding. So I'm going to click on time series, and I think you're going to like this. So as I do a sort here and compare it to its nearest neighbor, which was 1943, it bested its previous record by, about 3 inches or so. So that's also an impressive new record. You can look at, like I said, multi-month time periods, and for the sake of time here, because I know we can't be here all afternoon, you can look at year-to-date for a particular location. So how is Barton County looking for the year so far? It's definitely on the wet side. If I do a sort, I know it's the second wettest based on the rank of 124, with 125 years being the wettest year. So it's the second wettest year, second to this particular year. So if I do a sort by 125, I know that's the year 1990. Year-to-date through May was the wettest year-to-date period through May for Barton County in Missouri. But that just looks at precipitation. I'm thinking we probably don't have much time to go through temperatures. I think you probably get a feel. You could, like I said, you have different parameters that you can select from. Precipitation was the bigger cell, I think, for this particular month. There are other times when temperatures are really cold or really warm, and you want to look at an analysis of those. And you can do it very quickly and very simply just by navigating the various menus and selecting the variables that are of interest to you.
Can I
yes,
jump in?
Please.
So while Karen has this menu open, something that we take for granted here, but probably need to say out loud, there are 3 temperature variables that we list here. Maximum temperature is basically the afternoon highs. Minimum temperatures are the morning lows. And then the average temperature is the average of those for the day, so it combines those two. So if you're sensitive to afternoon temperatures, you would want to look at maximum temperature. If you're sensitive, or if your crops are sensitive to morning time temperatures, then minimum temperature would be the way to go. And they'll all behave just like the precipitation did when Karen was showing the data.
No, that's a really good point to mention. So with that, I think we're going to switch gears and get back into the presentation so that we can transition to our next slide. And the next thing we want to look at are our monthly climate reports. Not sure how familiar you are with them, but what we try to do each month is to summarize the weather and the climate events for a given month or season. So for instance, we just released our full May report this morning before the webinar. We've summarized May, we've summarized spring, as well as the year-to-date period. And we try and, again, provide that historical context, much like what you saw with the Climate at a Glance tool. Our data and our press highlights are available sooner in the month. We try, depending on where the business days fall on the days of the week, it's generally between the 6th and the 8th day of the month. We'll actually release our data, release the highlights report with high-level bullets. And then the full report is generally available somewhere between the 11th and the 13th day after the end of the data month. The pieces of our report, we do a national summary, which is just like an overall highlights, the big picture. We have a drought summary that includes our U.S. drought monitor. We have several authors here within NCEI who participate as authors, and a lot of other people who participate in the discussion. We have general wildfire statistics, and then we have some seasonal pages and reports. Snow and ice during the winter season, tornado report when there's action and activity during the warmer season. And then we have a tropical cyclone report during the tropical cyclone season, as well as all year we have a more detailed synoptic discussion for folks who really want to kind of get into the nuts and bolts of what are the drivers for what we're seeing happening. And that's full of a lot of rich content. Of interest possibly to you all might be some of our supplemental information, and we'll try and take a look at some of that this morning as well. Our supplemental pages, they can vary from month to month. Sometimes we're testing out a new product. Sometimes we want to highlight some things that are happening more locally and drill down into local statistics, which can be of great use to folks in the field. Our regional climate centers also provide specific regional and rich input each month that we'll take a look at very briefly. And so if you're looking for regional highlights, that would be a great place to come if you'd want to see a simple summary of some things that they've provided. So with that, we'll pretend like we clicked on the link at the bottom, and we will go to our State of the Climate summary. So if you happen to come into, if you don't bookmark this particular page and you happen to come into the main NCEI page, which is still an ncdc.noaa.gov URL, I always find it easiest to go to the How May We Assist You bar here, and the very middle item here will take you right to everything monitoring. It kind of takes you right to our pages. So our climate report, as I mentioned, we have all these sub-pages that make up and comprise the report. We also have similar features for the global, which we won't go into today. So as I said, we just released the May full report this morning before the webinar, and so I will click on Submit because I would like to take a look at that full report. And at the top, you will see several navigation bars that will help you. If you're interested in maps and want to look at ranks and colors of maps, you can navigate the single month, the seasonal, 6 months, rolling 12 months, and year-to-date menus, and we'll take a look at that in a second, but that'll give you a whole page full of maps at various scales from the national all the way down to 5-kilometer gridded, and you'll have anomaly maps, rank maps, value maps. It's all over the place, and not only just for the contiguous U.S., but also for Alaska as well. There are maps on interactive maps for very warm, very cold, very wet, and very dry areas, and then links to Climate at a Glance, which we've already looked at, our U.S. Climate Extremes Index, which if we have time, we might give some time to that. And then we also, like I mentioned, our regional climate centers provide regional highlights. And if there's a certain region you want to, click on, you can just go straight to that from the top of our menu. One of the things we like to do each month, which is a little bit subjective, but we try and space out the items that we select, but we try and hit some of the more extreme or more interesting climate events or weather events that have happened in the most recent months. So, for instance, for those of you who haven't heard, we broke a record once again for the second month in a row for the wettest 12-month period on record, not just for June to May, but for all 12-month combinations. Our drought footprint remains really tiny throughout the contiguous U.S. As you all know, we had a huge tornado month across the U.S. and a lot of the central part of the U.S. as well as parts of the East were hit really hard with that. We had record heat in the Southeast, still had places in the Rockies and in the West, in the mountains, as well as Duluth, the northern tier, that had some interesting snowfall in May. And so this in particular it's just kind of selected highlights to put on a map. I mentioned our supplemental pages that we have that might be of interest to folks. And I actually find, for me, this is kind of like, I don't know, if you have a little extra time and you want to kind of just browse, I would always recommend you come here and you just do some hunting and pecking. But if I go to like the spring temperature anomalies page and click on that, it takes me to a wonderful table that, again, I can sort by column. So that what I like to do for these cities, I like to either sort based on their rank. So I'll click on the rank, and you'll see that 2 stations came out as warmest, probably no surprise, Alaska being warm. We've got West Virginia being warm. We have Rapid City being second coolest. That's also probably not a big surprise. And then we have Asheville and many other spots that are third wettest. If you are someone who's really into statistics, you might want to see what was the most unusual statistically of the cities, and you can click on this and you can see that Barrow has a 3.3 standard deviation, and so you might want to search from that. You might want to search based on years in the record. You might want to search by something else, whatever suits your fancy. And then if you were to click on each of the ranks is a hyperlink to a Haywood plot, and so what you see is very similar to what you saw in Climate at a Glance. It'll start, in this case, it's a spring Haywood plot, so it starts at the beginning of March and it goes to the end of May, and you have your normal line, your historical average, and then you have the 5 coolest, 4 coolest, 5 coolest, and your wettest in red, coolest in blue, and then you have your current in this bold, thick green line, and it tells you that it's the second warmest here for Norfolk, Virginia, and it gives you some values here as well. So and then of course you have the light gray shadings are all of the other years that fell sort of in the middle of the pack, so to speak. But these are kind of fun. You can look at these for both temperature and precipitation for any of the cities that we happen to highlight. And you can navigate. I will go ahead and hit the back arrow just so that we don't lose our footing here. But we have the same for precipitation. We have what we call our record setter page, which is just a way to kind of pictorially plot, where some of our records were broken with a very, very short summary. Year-to-date anomalies. I probably should have changed. Same sort of functionality here. So instead of looking at spring, we're looking at our January through May period. We have some interesting maps. We call these our Argyle Maps. These help us visualize from a 5-kilometer perspective. So if you look at a particular grid box, we compare that grid box with its own history. And in this particular case, we wanted to do analysis of the June to May time period and see which particular locations have not had a wetter June to May period other than the 2018-2019 period, which is represented by this darker color throughout much of the mid-Atlantic and the Ohio Valley here and parts of the Central Plains and the Midwest. We also try to, at the end of a season, kind of show at the next season, kind of give a highlight of maybe something to come or something to look at. But we look at record heat, both from a mean temperature, minimum and maximum temperature. We see like 2011, for instance, in Oklahoma and Texas was wicked hot in the summer months. 1934, a little bit higher. 1936, if I'm looking at the colors right, a little bit further north and a little further east. So these are kind of fun to look at because they have such irregular shapes, but they kind of give you a sense for what years were sort of the big spatial winners when it comes to extremes. And we do that, like I said, for cold temperatures, for warm temperatures, for maxes and mins, and precipitation as well for the season. So those are kind of fun. They kind of give you an eye for, what's happened in the past in the coming season. And then we have a big thing this past month was 100-degree days. So we have a page that we devoted to places that experienced 100-degree temperatures early in the season. For some of them, the earliest that they've ever seen in the calendar year. So throughout the Southeast, we had a lot of locations that hadn't seen 100 degrees in May. And again, you can sort by the bar at the top of the table. And then to sort of just take you through some of the highlights of the report, I won't get into the details in particular, but we provide bulleted summaries with some hyperlinks to some images that help support the text. So the type of record that may have been broken, what the highlights were. We cover the contiguous U.S. We try and throw a little Alaska in there, as well as looking at record high and low temperatures. And we also do an analysis for precipitation as well as temperature. We summarize the drought monitor and then any other notable events that might have occurred that maybe aren't directly related to temperature or precipitation, we might indicate here. And then if it's a month where we're summarizing a season, then we do the same thing for the spring season, and we do the same thing for the year-to-date period. But what I did want to point out here before we move on is that at the top, I mentioned the regional highlights. So for instance, if I'm interested in what the High Plains submitted in a given month for like the granular type of information that may have impacted the region, I click on that link and it takes me to a bulleted list that the High Plains Regional Climate Center provides to us. And it will tell you what they considered to be important about what happened in the previous month, and they put it into context. So they tend to get into a lot of the impacts. And so if you're looking for some real specific information, this is a great place to go in our national report. If I go back to the top of the page, I also mentioned that we have temperature and precipitation rank maps. So I will, for instance, click on the May 2019 link, and it will take me to a filter and products that I can select, and a whole page of maps that are national, regional, statewide, divisional, county-based. We have county maps, so you can take a look at where the records occurred, where it was warm, cold, wet, and dry. This is really useful, and you can download these images if you're interested in them. I mentioned that there's also, beyond just the national climate report, we have other specialized reports that might be of interest to you. So for instance, drought would be a big thing to want to take a look at if you're interested in how drought is, or lack of drought is faring in your region. You click on submit, and it will show you that quite a bit of the U.S. is very, very wet, with the exception, short-term drought in the parts of the southeast. So you can navigate your way through the various tools. We even cover through the U.S. Drought Monitor, the U.S. affiliated Pacific Islands, which is a real great reach for us. So you can go through the drought discussion. There are lots of hyperlinks in here to various resources that help provide context for what's being said in the narrative. A lot of Drought Monitor side products are embedded in here as well, which is really exciting. And various drought indicators are summarized because they tell different stories at different time scales. So, it's a real great, general place to land if you're interested in how drought is evaluated for your region of interest. So that's really a really helpful page. Other pages that might be of interest, if you're interested in tornadoes and tornado impacts in your area, we have a tornado report, which there was a lot of action, as I mentioned, this past month, so you might want to go to this page, which summarizes the year-to-date statistics, and we have a nice interactive plot here, a time series that tell you what the numbers are for the individual years. And then I said if you're into really data-rich content, you want to really drill down into the, what drove the weather for this past month, we have a synoptic page, which is our heavy-hitting page. It really gets into the particulars, and it looks at circulation patterns, atmospheric drivers, global links. And like I said, this is really for someone who really wants to get into the nuts and bolts of the climate system, the weather patterns, what's like I said, driving what we saw, what patterns persisted through the previous month, and so forth. So, yeah. So feel free to, navigate when you have your own free time. You can look at past reports as well. You don't have to just look, but we don't go back and re-summarize previous reports. I think that's an important point to make. We save the report for the historical perspective. If you want what's the most recent information, you always want to go to our dynamic tools and re-look up the data, because the data values and the ranks and so forth will update as time proceeds, as we quality control more and more data. So the reports are a great first glance and a great historical for posterity's sake. But if you want the most recent data, you definitely want to go to, say, Climate at a Glance, or to our maps, which are updated every single month.
Karen,
yes.
This is Doug.
Yes.
There may be quite a bit of interest in the regional aspect of Climate at a Glance.
All right.
Can you show the options, the regional options. Let's put it that way, and maybe show some river basin information, if you will, with precipitation, and maybe even start with May.
All right. Okay, so I've gone back for those of you who didn't follow. I clicked on regional. I went to mapping so we could visualize, and then I selected as my region river basin. We have, this is, I don't want to say an ever-changing list, but it likely will continue to evolve and grow as we, more and more regions, regional data, it depends on the use, and there are different user groups and industries that actually prefer different types of regions. So we've got river basins here, and if I hover over the upper Mississippi, we see it was record wet, and I'll click on that in a second. The Missouri was second wettest. Arkansas White-Red Basin was also second wettest. So yeah, you can see, and as we pull further away from the central U.S., it becomes a little less wet. So I guess for the sake of discussion, do you have a preference, Doug, which basin I click on?
Oh, upper Mississippi is just fine.
Okay. All right. We'll go with upper Mississippi then. All right. So we know it's the record wettest. I want to take a look at a time series, though, and see how that compares to previous years. So if I sort by rank, I see.
Doing 1 month versus year to date.
Oh, that was year to date.
Remembered year to date.
I was like, why did that statistic change? That doesn't make sense. So second wettest year to date, if you were following along there. So yes, we've eclipsed the previous. So if I sort by rank, thank you for catching that. 2004 was the previous record wettest upper Mississippi River Basin with 6.88 inches, and this May we eclipsed that with a little over 7 inches. Again, it's the same navigation method that we did with the states and with the county and so forth, but you can reselect if there's another, if you're looking at the type of output you want and you want to see for a neighboring basin. So I can go to the Missouri and just kind of slide over and then click on plot, and I can see the same type of analysis but move from basin to basin. So it's nice because you can drill top down in, and then you can move laterally within the tool as well. So there's a lot of useful functionality because everybody's brains work differently, and we process data in different ways. And when you find the product you want, it's nice to know that you don't have to back all the way out to back all the way back in and find it for another region. So in this case, we just kind of slid literally horizontally on the map to another basin to look at a similar, the same analysis, but for a different region.
Do you mind selecting just the drop-down menu for region?
Yes.
So just scrolling kind of up and down through here, you can see kind of there's the climate regions that we've defined on the top, and those were chosen to include states that have similar climates. There's some miscellaneous kind of by request regions. We think we're going to be able to add the entire Mississippi River Basin in the next couple of months. There's various jurisdictions, like the Weather Service has unique regions, and then river basins themselves. And I believe we have one more, ag belts. So basically either productivity weighted or area weighted agricultural belts. So these are we didn't look at climate divisions. They're kind of between counties and states. There's a typical good kind of middle of the country state will have 8 to 10 climate divisions in it, and these are the climate divisions that, as of the last ag census, were active in these various types of crops. So we kind of lump them all together to get a poor man's look across a commodity. It's not perfect, but it does kind of give you an idea of how the winter wheat crop is experiencing temperature or precipitation above or below average and all of that. So that's kind of the logic behind that. And like Karen said, this list we're actually kind of slow, I wouldn't say constantly tweaking like you said, but
right.
We're always taking input on what we can
what's really
add
needed.
To this. Yeah.
Right, yeah. And I know, like, for instance, the Weather Service, they would like to see their county warning areas included, and that's something that's on our short list. But yeah, so if you all have input on some regions that we're missing that would be widely used by a large group, because we tend not to cater to individual requests as much as trying to help entire sectors or groups to benefit a wide variety of people. So that's kind of how we, prioritize our list.
And Doug would be your point of contact, yeah. I think, on that, and he can help coordinate. Sorry for volunteering you, Doug.
Oh, that's fine. Part of the job. The other really cool piece that you might want to show while we're just sitting here or on this page is just very briefly, because I know this can get sort of detailed. Talk about the trend or the time series, the trend ability to put the trend in here.
Yeah, I had a feeling you were going to point us there, and I'm sorry for overlooking that, but you can change for this average that's listed on the map. You can change the base period. Our default is a 20th century base period for our, our regions, for our states, for our divisions. It's not practical for cities because not all the cities have that period of record, so it will default to its period of record most likely. But that's the default base period. If you want to look at a shorter base period, a more recent base period, you can modify the base period, but you can also add a simple linear trend. So for instance, if I want to see if there's some, increase or decrease over time in the precipitation for May, I can click on a per decade, starting at the beginning of the record, ending at the end of the record. I can even decide if I want to add a smooth time series, so something that takes out the erratic wiggles and just kind of smooths it out a little bit, but it's between a line of best fit and the actual May plot. So I'll add both because you'll be able to distinguish visually, and click on plot. And so you'll see the blue trend line. So there's an increasing linear trend, and it tells you at the top it's 0.04 of an inch per decade on average. And our filter, which is in red, shows it's kind of on the decline in the early part of the 20th century, and then kind of goes up a little, and then down, and then back down, and then it's kind of been up-ish for several years since about 2005 or so. But you look at the interannual variability, and it's it looks like you're having palpitations or something like that. So it's kind of the smoothness says it's still elevated, but from year to year, there's a lot of variability. So these are just various analysis tools that help you, decipher visually and also quantify some of the things that we're seeing throughout the historical record. But I'm glad, Doug, that you pointed that out, because that's an important point to note, that you do have options over here in this options area. I realize we have about 10 minutes left, so I'm kind of thinking I should probably stop with the demonstration, and if there are other questions or other pieces that folks want to take a look at or want clarification on, that's probably the best use of our time at this point.
Right. I'm looking here at any kind of comments. Anybody have any questions or comments, feel free to whoops, let me make sure I got that. Oh, just a comment saying those regions would be good for our ag partners and such. Someone was saying. Oh, yeah. Please go over the Climate Extreme Index. That was another request.
All right. So we'll kind of go straight here. So the Climate Extremes Index, clearly, it's hard to quantify extremes, and so this was developed as a way to try and help decision and policymakers, take a look at the historical records, see how our extremes in temperature and precipitation and drought and wetness and days with precip, how all of this has changed over time. So what you can do is you can look at the main landing page is a composite of looking at maximum temperatures. In fact, I should probably, just so you can get a full picture, there is a formal definition for what the CEI incorporates. It doesn't have to have all of these, and it isn't limited to all of these. It's something where you can add additional extreme indicator pieces or components if you have sufficient information and data. So it's very flexible. So we're looking at maximum temperatures, and we're looking at max and minimum temperatures, step 1 and step 2, that are much above and below average. It's kind of like looking at a football field, and when you get into the red zone, you're like 10 yards from the goal. We're looking at those extremes in the tail, so the top 10%, the bottom 10% of all occurrences. That's what we're looking at here. For our third indicator, we're looking at severe drought based on the Palmer Drought Severity Index. So if you're in the bottom 10% of occurrence, you're in drought. If you're in the top 10% of occurrence, you're in extreme moisture surplus. We look at the value of the percent of the U.S. with a much greater than normal proportion of precipitation derived from extreme one-day precipitation events, and that's a lot to say in one sentence, but basically what we're looking at are heavy, short-term precipitation events, so heavy one-day events compared to, say, the annual precipitation. How is your precipitation falling? Is it falling over a lot of days and a little bit here and there, or is the majority of it falling as intense, single day or multi-day precip events versus, spread out nicely? So this helps to try and capture that. And then we're looking at the number of days with precipitation, the number of days without precipitation. And again, everything we're looking at the tails. So we're looking at the most extreme events. So when we look at a graph of this is a plot that looks at the annual. The default is the annual composite, like, crashing all of those pieces into one thing. And we see that, since the, early mid-70s, we kind of see a general uptick in the overall number or percentage of extremes. So what we're looking at is the percent area of the U.S. on the y-axis. So for instance, if we look at, if I sort by year, because I can sort. So for 2018, about 33% of the contiguous U.S. on average experienced extremes in the various variables within the CEI. And an average would be 20%, because as I said, the one tail is on the either cold or dry side, the other tail is on the warm or the wet side. And so if you add those two 10% tails together, you get an average of 20%. So we would say that 2018 was an above average year for extremes, as with many of our most recent years. Yes, question?
Yep. There's one more question, but I just wondered, first time I've actually looked at the regional climate extremes index. I'm not sure if there's enough time to actually describe that, other than that does exist.
Yeah, clearly the national version of that has a very limited use, because it is just sort of a paintbrush of everything all averaged together. So sometimes you'll have extremes in one direction, extremes in the other, and when you average them, they may be less extreme, or it may compound it. So I personally like looking at individual indicators, and I like looking at regional output. The goal eventually would be to take regional output and maybe have state or other types of smaller subsets, because it becomes even more powerful the smaller the regions that we have. We think there's a lot of utility in that, and we hope to go there at some point. But we have here the standard climate regions that we've highlighted. So for the same kind of information broken down now by region. So we know it was above average, it was about 33%. And we know what parts of the country now were most impacted by that. And it wasn't the Northwest, the Northern Rockies and Plains, and it wasn't the South, because they were somewhat near average. It was really the Western and the Southwestern U.S. and the Ohio Valley, Northeast and Southeast. So there's actually a data table, which at first glance might give you a headache. But if you take the time to just kind of look at the colors and look at the percentages, and you're interested in regional output, each region or the contiguous U.S. is a separate column, and then we break down by each 10%. So the extremes in your daytime temperatures, your warm daytime temperatures, your extremes in your cold daytime temperatures. Same for minimum temperatures, your wet, dry PDSI, your one-day heavy precip events, and days with and without. So what you can take from this, so let's look at the Ohio Valley. So Ohio Valley is this column here. The CEI was a 37% coverage across the Ohio Valley, but if you break that down, most of that came from warm minimum temperatures from wet PDSI and the number of days with precipitation. And for anyone who lives in that region, that probably doesn't come as a shock, but this helps to quantify what the components are and how much contribution came from each component. So, and you can click on, for instance, I can click on, let's do this, warm minimum temperatures. I'm gonna click on that real quick here, and it will take me to a time series plot. So that it'll show me from our start year, which is 1910 for these data, all the way up through 2018. And you'll see that clearly in the most recent decades, really since about 1990, it's been almost all extremes in warmer minimum temperatures and not so much a story about cold minimum temperatures. So it takes a look at, so the bottom tail is the cold is on the bottom, the top are the warm minimum temperatures, and so they plot them side by side so you can see how they vary with time. And then, as with most of our output products, we have the table that falls below, and you can sort by year, by which the warm records and by the cold records.
So a couple other questions are, is there an easy way to save any of these images? I know from my experience, I pretty much right-click on them and copy them, but is there an official way to do that? And I think we're talking about the maps as well as maybe the graphs.
So the maps, if they're from that big catalog of maps that Karen showed, you can just download those like you would download any image from the web, and I'm talking about the State of the Climate Report.
Oh,
map.
okay, yeah.
For the dynamic stuff, for the climate at a glance maps, is there a right-click option on that? I think.
Yes.
So you can right-click on a PC. I don't know what the tool is on a Mac, and then you can do Save Image As, and it'll be the common format: PNG, JPEG, GIF. Mm-hmm. You can download the graphics like that. The maps you can do in a similar way, or if you want to preserve the exact size and zoom that you had, you can use any kind of screen Windows snipper tool or something like that.
And then another question, it says, I'm curious about the data products that are used to compute the statistics. It looks like the archives go back 100 plus years. So I presume point measurement data is gridded in some way prior to the 1990s. Then I'm also curious about how many different radar products, for example, make up the gridded data archive from the last 20 years.
So these are all, that's correct. They're all gridded from point observations throughout the history, even last month. So from 1895 through last month, the area values are derived from gridded fields based on single station observations. And then the statewide average, say, is like a cookie cutter through that gridded data set. So there's a Nebraska-shaped cookie cutter that we use to determine the Nebraska average. This does not include what we call remote sensing. These are all in situ, station-based, rain gauge-based stations. We don't have satellite or radar information going into these. It's not because that's not good information, but because the limitations with that, radar and satellite do have a difficult time pegging exactly how much rain has fallen, particularly in a very heavy rain situation. They can definitely tell you where it rained more or less, especially between stations, but getting an exact value out of them is still a challenge. And then, of course, there's also the issue that they only come online in the last 20 or 30 years of the record. So the station value for temperature and precipitation, anyway, is the superior observing platform, and it's also the best way that we can do apples-to-apples comparisons between today and the past.
Right. So it's really contextual. It's very contextual on how you use the information. And if you're just interested in how much rain fell in a particular basin over the last month, you can probably use radar data and lots of other information. But if you wanted to try and compare that, if you want to compare apples to apples through the past, you've pretty much got to use the in situ data or the data on the ground as opposed to satellite and radar.
That's right, and we've got people here that are dedicated to trying to blend remotely sensed information with station-based information. It is a very challenging field. There are lots of apples and oranges questions. Even you know, when you change the type of radar that's deployed, you have that same issue all over again. So it is a challenging field. It is a promising field. We'll eventually get there, but for now, especially the context, this is the best tool that we have. We didn't get into temperatures and climate at a glance, but those have been corrected for basically outliers. You know, when a station went wacky, they are corrected. It corrects for the urban heat island effect. It corrects for known and detected station moves for temperature. If you move a station up and down a hill, that can cause an artifact in its own history. Those are kind of detected and corrected for. It's the best approximation out there for the U.S. climate history.
Yep. And I want to thank you both. We're at 12, or a little past 12, or noon here in the central region. So I want to thank you both for your time and your effort. It seemed, for me, informative. There are some email addresses. That's great. I was going to ask you about that. If people have specific questions, they can email you. And if you want to go to the website, I just type in state of the climate when I want to get to all that stuff, as opposed to going to the NCI website. So that's my shortcut.
And just so you know, I mean, Karen is the author of the national report and kind of coordinates all of the inputs for the other different kinds of reports. So if you know, I'm the chief of the branch. Karen is the kind of lead scientific author on those national reports. So if you email either one of us, we're directly involved in all of these.
All right. Thank you, Karen and Deke. That was very helpful. We appreciate it very much.
Our pleasure.
Yeah, you bet.
Yep. And talk to you all later. Thank you very much for participating.
Thanks, everybody.
Bye-bye.